I wanted to do two questions from the homework just to help you out a little bit with graphing piecewise functions as well as creating the equations for piecewise functions. So if you take a look here, this is actually question 1a, and it's going to ask you to graph f of x, and f of x is actually three pieces. It's x plus 6 if x is less than or equal to -2, x squared if x is between -2 and 2, including 2, and then x plus 2 if x is greater than 2. So what we notice here is that we've got three different pieces, and things are going to be happening when x is at equal to -2 and when x is equal to 2. So the first thing that we're going to do is we're probably going to try to make a grid that is going to help us out a little bit here. So I've got grid paper, and I'm going to make my x and y axes. So let me do that. Let's insert. Let's draw some lines to help me out here. So I'm going to make, here's my y-axis, and then I'm going to make my x-axis. There we go. So here's my x, and here is my y. So in this case, I'm probably looking at trying to go up in a decent scale. So what I'm going to do is I'm going to go by 2, 4, 6, and then 8, and then same thing here, 2, 4, 6, 8, 10, same thing, -2, -4, -6, and then -2, -4, -6, -10, whoops, -8 there, actually, -8, and then -10. So I've got my x and my y-axis all scaled and ready to go. And then now what I'm going to do is I'm going to take a look at where everything special is happening, right? So I know that something's going to be happening when x is at -2, and something's going to happen at x equals 2. So what I'm just going to do there is I'm going to put a gray dotted line. You can erase it after. It's just that when I do it this way, it helps me kind of see the different sections. So I know that something important is going to happen at x equals to -2. So something's going to happen. And then I also know that something's going to happen between at x equals to 2 as well. Those lines will disappear after. I'll erase them. So let's start off with the first portion. So the first portion here says when x is less than or equal to -2, the function that represents that portion is going to be x plus 6. So for all of your x values that are going to be less than -2, we're going to graph it as if we were graphing x plus 6. Now, I don't care how you graph this. You could use the table of values. You could use 2 points on this line. But we know that at x equals to -2, that's part of this portion. So if I plug in -2 into x plus 6, that's actually going to give me +4. So if I take a look here, I'm going to do this portion here in red, which is why I'm highlighting it in red. And so that means at -2, I've got +4, and it's a closed bubble because x equals to -2 is part of that domain for that first section. And now I need to graph it where it's x plus 6. So like I said, you could use a table of values to help you. So you could plug in x equals to -3. If you do that, that's going to give you +3. So that would give us this one here as well. And since we're dealing with a line, if you already know 2 points to your line, you can connect the dots to create the first portion of your piecewise function, which is right here. So that red line represents the first portion of our piecewise function. Now, we have our second portion now, which is between -2 and +2, and it's including +2 in the second portion. So for this second portion here, I'm going to graph it using blue, and I'm graphing x squared. Now, at -2, x squared is going to give me +4. So I actually have a dot there. It's already closed. So that belongs to the first portion. And then I know that if I'm graphing a parabola, again, you can use the table of values. You can do your x values between -2 all the way to 2. I know that at the end, it includes x equals to 2, which means there's going to be a closed dot at x equals to 2, and I'm going to create myself a parabola. So if I create myself a parabola, this is what I've got going on. Let me fix this parabola. It's a terrible parabola. But I'm drawing on it so it's not picking up my lines the way that I usually draw a parabola, but try your best to mimic the best parabola that you can make. There we go. So that deals with that second portion of my piecewise function. And then the last portion, which is what I'm going to do in purple, is x plus 2 if my x values are greater than 2. So in this case, any x values that are bigger than 2, I'm going to be graphing it as if I was doing x plus 2. So for me, I'm going to start at x equals to 2 first. So if I do 2 plus 2, that's going to give me 4. So I know that it starts at 2 and 4. And then I'm graphing it as if it was x plus 2. So the next point that I'm going to create is when x is equal to 3, and that's going to give me 5. So that's going to be up here. And so since I know 2 points, I'm going to connect my dots now. And that's what we've got going on. And there we go. That's the piecewise function that represents f of x. You have x plus 6 for x values that are less than or equal to -2. And then between -2 and 2, and including 2, you have x squared representing that portion. And then any x values that are bigger than 2, you have x plus 2 representing that portion. And like I said, at the end, once you're done, you can erase the gray dotted line that you created to help you separate your xy plane into those different portions so that you know where everything goes. And so there we go. That is the piecewise function that we graphed. So take it slow, right? Do what I do, put in those dotted lines to help you so that you know, like, this particular portion should look like this particular portion should look like this, and then the last portion should look like that. Now, in this particular piecewise function, it all connects very well. That's not always going to be the case as you do some of the other piecewise functions. You are going to have gaps in between the different parts, and that's okay. Just be aware that if your domain includes the x value, then that particular portion of the piecewise function should have a closed dot, versus if it doesn't include, a particular x value in the domain, then you should have an open dot. So remember interval notation from advanced functions. Include means the circle is filled in. Doesn't include means the circle is not filled in. Let's take a look at another example. This time I gave you the graph and I want you to create the equation for me instead. So this one's actually question B on the same page. So for this one here, I gave you a piecewise function. Now in this particular case, I don't have arrows on any part of my piecewise function, which means it doesn't go on forever. It actually stops at a certain x value. So if I take a look at this graph, remember what I said, indicate where things are happening, at which x values things are happening at. So just from looking, I notice that I've got something happening when x is -1. And I also know that something is happening when x is 2. So that tells me that I've got 3 different intervals to look at. Okay, so let's take a look. So I'm going to call this whole thing here f of x. And if I'm dealing with f of x, I know that it's split into 3 sections, which means there are 3 pieces here. So if I take a look at my 3 pieces, let's start off with, we always start off with the leftmost, okay? So the leftmost part is the one that I'm going to highlight in yellow. So this piece here. So this piece here is dealing with between the x values of -4 all the way until -1. So in this particular case, I'm dealing with my x values between -4 all the way to -1. So when I write my domain here, this is dealing with if it's between -4, and I'm not going to include -1 in this particular case. For this one, it's okay because they meet at x equals to -1, so you could, I just chose not to. So we have to figure out what's the equation of that line there then. So this is going to bring you again back to grade 9 to help you remember this. So this particular line has an equation of x plus 4. So you could use slope and then your y-intercept if you were to extend your line, or you could use 2 points on that line to figure out the equation. The next portion that we're going to take a look at is between -1 and 2. So in this particular case, I'm going to use blue to represent this portion here. Okay. Now be very, very careful. Since I didn't include -1 in that first domain section, I'm going to include it in the second part, okay, because they were connected. So in this case, like I said, we are dealing with between -1 all the way to 2. Now notice here at x equals 2, we've got this space in between one piece and the other piece. This is the part you're going to have to be very, very mindful about which part has the closed dot. In this particular case, the portion that I'm looking at actually has the closed dot, which means that x equals to 2 is part of this particular piece. So my domain here would be if between -1 and it equals to -1, and it also is less than or equal to 2 because of that closed dot there. So we need to figure out the equation of that parabola that's represented there by that I highlighted in blue. In this particular case, this is just -x² plus 4. And then we have our last portion, which I'm going to highlight in green, which is this part here. Okay, and that part deals with between 2 and then all the way to 5. And if you take a quick look at that portion that I highlighted green, at x equals to 2, that's not part of that piece. But at x equals to 5, we've got a closed dot, which means it's part of that piece. So my domain here is going to be if my x is between 2, but it doesn't include 2, and less than or equal to 5. It includes the 5 there. So the equation that represents that particular piece is just 4 for us. It's a horizontal line. And there we go. We've created the piecewise function that represents the graph that we were given. So like I said, if you're ever asked to create a graph or to create the equation for a piecewise function, always remember to notice where things are changing. That is going to give you those breaks in your domain. That's going to separate it into the number of pieces. And then take each section and figure out the equation. And then you'll be able to figure out your piecewise function.